This question doesn't have a diagram, so the first thing you have to do is sketch out the diagram just so you can visualize what's happening. Okay, so we've got an object on the plane. The angle is 25 degrees. Coefficient of friction between the object and the plane is 0.3. A force of magnitude T newtons acts on that object in a direction parallel to a line of greater slope of the plane. It's basically there. Resolve the other forces. Because it's going to be slipping down the slope, friction is going to be operating in that direction as well. You've got the normal reaction of the slope there, and we've got the weight of the object coming down. Okay, so we're going to find out that the object is just prevented from sliding down the plane. As it's just prevented, the friction is maximum. We need to calculate the value of T. So first of all, we're given the coefficient of friction, so we're going to use F max equals mu r to find out what the actual friction force is going to be. R, this normal reaction, is given by mg cos theta. So putting the values in, we have F max equals 0.3 times 75 g times cos of 25. So the calculator, 0.3 times 75 times 9.8 times cos 25 is a value of 199.84 newtons. Because it's just prevented from sliding down the plane, if F is this value, pushing it down the plane is going to be if you remember mg sine theta, remember sine for sliding down the plane. If it's just stopping, then this one has got to be equal to F max plus whatever that force of T is. So T will equal mg sine theta, take away F max. So into calculator, so we got 75 times 9.8 times sine of 25 take away 199.84 gives a value of 110.78 newtons. For the next bit, if t was 0, find the magnitude of the acceleration of the object. Okay, so now t is 0, my object here, I've got the frictional force working in that direction, I've got mg sine theta working here. The coefficient of friction is exactly the same, so the force, resultant force, equals mg sine theta take away F max. Which we know from above is 110.78 newtons. And now it's working down the slope. So if F equals ma, and we know the force down the slope is that, the acceleration would be 110.78 divided by the mass of the object, which is 75. So divided by 75 gives an answer of 1.477 and its acceleration, so meters per second, the -2.